Hi everyone, thank you for taking your time to attend my session. I'm Teppei Fukuda from the open source team in Aqua security and the maintainer of Trivy, which is a vulnerability scanner for container images. Today, I'll be talking about vulnerability handling with OpenPolicy agent. There are a lot of software vulnerabilities in the world. Usually, CVID is assigned to each vulnerability. In the case of Heartbleed, CVE 2014-0160 is assigned. Do you know how many vulnerabilities are reported per year? This chart is from NVD, National Vulnerability Database, basically listing all CVE-ID assigned vulnerabilities. In 2019, there were 17,000 vulnerabilities disclosed. As you can see, the number of vulnerabilities has increased year by year. In other words, about 47 vulnerabilities are reported a day. Basically, you have to understand how vulnerabilities work in order to know how much impact it is. But it's not easy. You might take a few hours to understand only one vulnerability. 24 hours is not enough to figure out the 47 vulnerabilities. If your organization has a huge security team, you might even be able to do that. But you should not do that since 47 vulnerabilities have a lot of noise. It may include vulnerabilities of Windows, OpenSSL, Python, Kubernetes. What if your organization doesn't use Windows and Kubernetes? You don't need to look into those vulnerabilities. So, asset management is essential for this purpose. You should know which OS, package, programming language, library, and equipment are used in your system. If you remove vulnerabilities related to software your system isn't using, you can reduce vulnerabilities you have to look into. For example, it might be 5 or 7 vulnerabilities depending on your organization. Should we do this process manually? Let's think about a container image. A container image should include all software it's gonna use. All you have to do is extract information from the container, like the image is based on Debian and uses Java, then cross-reference to security advisories from vendors. It sounds easy, but it's still hard to do it for all container images manually and periodically. For that purpose, you can use a vulnerability scanner, which automatically does the things I explained just before. There are many security solutions in the cloud-native area, mixing open source and commercial products. It also includes Trivy I developed. Applying vulnerability scanning reduces the number of vulnerabilities you have to investigate. Do you think 5 or 2 or 10 vulnerabilities are small? This number is just an example, and it should be different depending on your system and your organization. But I'm sure it must not be zero. You will see some vulnerabilities. I don't think this value is small enough. As I told you earlier, it might take a few hours to look into a vulnerability. How can we reduce vulnerabilities more? Take a look at this chart. A vulnerability basically has a CVSS base score indicating the severity. The score varies from 0 to 10. 10 means the most critical. CVSS consists of 3 metric groups: base, temporal, and environmental. But in this presentation, I'll be talking about the base metrics and score, because NVD provides base metrics only. As you can see, there are not so many high-risk vulnerabilities. Only 5.7% of the vulnerabilities have a score of 8 or more. Filtering based on CVSS scores can further reduce vulnerabilities. It might be 0 or 1 vulnerability if you look into critical vulnerabilities only. Of course, 0 or 1 depends on your system. Let's consider whether the CVSS score is reliable. In the case of Heartbleed, which affects OpenSSL, the CVSS V2 score, it sets 5.0 median. According to the CVSS score, it doesn't look like it's a dangerous vulnerability. Can we think of this vulnerability as negligible and ignore it? As noted in this article, hackers exploited this vulnerability. So, this vulnerability is not negligible. In addition, the CVSS score is provided by each vendor. In this example, NVIDIA said the score is 9.1, critical, while Red Hat said 5.9, moderate. The values are often different. I'm not saying don't use the CVSS score, but it's a bit risky to rely on CVSS scores too much. We should define our own policy for vulnerability handling. For example, our container image uses bash, but we can accept the risk of bash vulnerabilities as bash is not internet facing. Of course, if you don't need it completely, you should delete it from the image. Also, you might be able to accept the risk of cross-site scripting if your system is a static website. And you perhaps can ignore the vulnerability which requires user interaction, like opening an email and clicking a link. This policy should be customized depending on your system and requirement. And the system managing customers' assets like bank account, and the system just publishing an article like the blog must have different policies. I recommend defining the policy for vulnerability handling. If the vulnerability is bash related or cross-site scripting or requires user interaction, then you'd classify it as a negligible vulnerability. If it doesn't match any rule, you have to fix the vulnerability by updating the version or something another way. Actually, there is some useful information for vulnerability handling, such as CVSS vector and CWID. CVSS vector string consists of 8 elements called CVSS metrics. Each metric value is used to score the vulnerability. For example, attack vector. This metric reflects the context by which vulnerability exploitation is possible. This metric value will be larger the more remote an attacker can be in order to exploit the vulnerable component. In addition to attack vector, you can find privilege required, user interaction, and so on. CWE, Common Weakness Enumeration, aims to provide a common base to identify the type of software vulnerability. For example, CWE 17.8 is OS command injection, and CWE 89 is SQL injection. Now, you can rewrite the policy using these metrics. If you want to know if the vulnerability is XSS, you can check if CWID is CWE79 or not. If you want to know if the vulnerability requires user interaction, you can check if user interaction in CVSS vector is required. So it allows you to handle vulnerabilities automatically. And I propose to use Open Policy Agent to automate vulnerability handling. Open Policy Agent is an open source policy engine and a CNSF project. You have to write a policy written by Lego and pass it to OPA with input JSON. OPA evaluates the policy and returns the result. It's usable as a library and a service. Now, you can put the policy into Lego. The policy written in Lego should be like this. On the right, you can see the vulnerability detail of the input. You can see the package name, CWID, CVSS score, vector. On the left, we can see the pretty simple rules. If the package name is bash or CWID is 79 or user interaction is required or CVSS base score is less than 7, the vulnerability is gonna be negligible. OPA should reduce the vulnerabilities to 0 or 1 a day, depending on the policy. It's so small that you could look into all. Note that vulnerability information is not always correct. If anybody says user interaction is required, it might be wrong. Don't trust the vulnerability information too much. Even if it's correct and their policy marks it as negligible, it doesn't mean there is no risk. It means you decide to accept the risk. The balance of risk and cost is important. If there are many people in a security team and your organization can take the cost of security, you may be able to look into the patches and the primary source of all vulnerabilities. If it's not the case in your organization, you probably need a policy to accept some risk. Here's a summary of what I've been talking about so far. At first, vulnerability scanning filters to only those vulnerabilities that are relevant to your organization. Then, OPA filters out vulnerabilities that you can accept the risk. This whole process is automated. You can just focus on the vulnerabilities in the final output. As a case study, here's a look at the OPA integration in Trivy. In this example, Trivy scans an image and detects vulnerabilities. Then OPA evaluates the result. Okay, so before that, let me explain Trivy a little. It's an open source scanner for container images. Trivy has a bunch of features, and especially it can be integrated into the CI system such as GitHub Actions and Jenkins easily. Recently, Trivy supported OPA integration to filter vulnerabilities. You can pass a Rego file defining your policy via -- ignore policy option. If your policy marks the vulnerability negligible, it will not be displayed in the result. The structure of each vulnerability input is the same as for the Trivy JSON output. It includes severity, CWIDs, CVSS vector, and score, and so on. Also, it provides helper functions in Rego, like pass CVSS vector v3, which converts CVSS vector string to an object so that you can easily access each metric. This example ignores some packages like bash, binder license, RPM, and Beam because they are not used in the production environment. As mentioned earlier, unnecessary packages should be removed from the container image. But if it's difficult, you can ignore packages in the Rego policy. Then vulnerabilities with low and medium severity can be accepted. Also, when it's not exploitable remotely, or it requires high privilege like administration, or needs user interaction, and they will be marked negligible in this example. Okay, so let me show the demo of OPA integration in Trivy CLI. At first, let's try scanning CentOS 7 without any policy. In this demo, the result detail is not needed, so I'm redirecting it to DevNull. We can see the number of vulnerabilities 622. It's a hard task to check all vulnerabilities. Next, looking into the policy example. As I explained, it ignores some packages, some severities, and a vulnerability that can't be exploited remotely, or requires high privilege like administrator, or requires user interaction, or cross-site request forgery in this case. Okay, let's apply this policy to the result to be showed. You can pass the Lego file via --ignore policy option. As you can see, there are 7 vulnerabilities only in the result with the policy. As you saw, the image CentOS7 shows 600 vulnerabilities without the policy, but it would be only 7 with the policy. Less is not always better. You have to tune your policy according to the requirement in your organization. At last, let me explain OPA integration in Kubernetes. This technique can be applied to any scanner. But as proof of concept, I developed a Kubernetes operator called Trivy Enforcer. It works as custom controller to scan an image in advance, and admission controller to validate an image a user tries to deploy. Let's take a look at the architecture. At first, a user registers an image name they want to deploy as a custom resource. Trivy Enforcer watches the custom resource as custom controller and fetches the image name. Then it sends the image name to Trivy server for vulnerability scanning. Trivy server returns the result, and finally, Trivy Enforcer updates the custom resource with those vulnerabilities. The scan result of the image must exist before you try to deploy it. Besides, a user needs to upload their policy to config map. Kube management provided by the OPA team watches config map and loads the policy into OPA service. What matters is you can take advantage of the same policy you use with Trivy CLI. And Trivy Enforcer calls OPA service through REST API. When the user is trying to deploy the image, Kubernetes API sends admission review to Trivy Enforcer, and the request contains the image name. Trivy Enforcer retrieves the custom resource that matches the image name and extracts the result of the vulnerabilities. If there is no scan result, it rejects the image immediately. Then it sends the vulnerabilities to OPA, and OPA evaluates those vulnerabilities. If one of them violates the policy, it returns deny response. If there is no vulnerability violating the policy, Trivy Enforcer allows the deploy of the image. All right, so I'll demonstrate how Trivy Enforcer works with Open Policy Agent in the Kubernetes cluster and prevents a vulnerable image from being deployed. At first, I'm checking pods in the default namespace. There is no resource, and checking the Trivy Enforcer system. So where Trivy Enforcer is deployed, it works as custom controller and admission controller. And also checking the OPA namespace, you can see one pod. It includes 2 containers. One is the OPA service, and the other one is kube management to load Lego file from config map to OPA service. Okay, let's check the config map. Get config map in the OPA namespace. So you can see the one Lego file, including helper functions. This Lego file is deployed by default by Trivy Enforcer. Let's check the content of this Lego file. Helper functions. Okay, as you can see, this Lego file provides a helper function like pass CVSS vector v3, converting a CVSS vector string to the object. Okay, you can import this package and call these functions. Okay. Next, you can see the same policy I used in the previous demo. Example Lego. It ignores some packages and civilities and some other rules as well. You can reuse the same policy in the Kubernetes integration. to make use of it, you have to deploy it as a config map. So let's running create config map and Trivy from file example Rego and namespace OPA. Okay, create it. Let's check the config map. Okay, you can see the Trivy config map. So this Rego file is uploaded to config map and loaded into OPA service through kube management. In Kubernetes integration, you need to define the package Kubernetes validating because Trivy enforcer queries it. So let's define the policy, webhook Rego. The package name must be Kubernetes validating Trivy. And import data.trivy. This is what we uploaded just before. Also, there must be deny rule message. But we already have the logic to evaluate the vulnerabilities in Trivy.ignore. So we can just call the imported rule here. Not Trivy.ignore. But the ignore means you can accept the risk, while denies that you cannot accept the risk. So we need a not. And you can define the message. So for example, the image forbidden. Okay, that's it. And also we have to upload this reg file to config map with config map with the name of the webhook. From file and open namespace. Okay, so there are 3 config map in the open namespace. Webhook imports Trivy. And also Trivy imports Trivy helper functions. Okay. We've completed the preparation of image assurance. So let me try to deploy NGX. Image NGX 1.18. So it was rejected because there is no scan result for this image. This is because we've never added a custom resource with this image name. So there is no scan result in the cluster. Okay, so we need to add a custom resource, including this image name. Okay, so this nginx.yaml has a kind image vulnerability. So this is a custom resource. The name is nginx, and image name is nginx 1.18. So before uploading, let's checking the custom resource. Okay, so there are no resources. So let's add it. Let's add this custom resource and check the. Okay, so now you can see the nginx custom resource. And Trivy enforcer watches this custom resource and it detects a change. So now Trivy enforcer scans the image of nginx 1.18 and updates the vulnerabilities. Okay, maybe it's already finished. Image vulnerabilities, nginx, YAML. So you can see the labels, the namespace, registry, repository, and tag. Also, you can see the status field. It includes vulnerabilities. As you can see, so there are vulnerabilities of this image. For example, the package name apt, and severity row, and the vulnerability ID CVE 2011 3374. Okay. Now we have the scan result of NGX 1.18. So let's try to deploy this image again. Field control run NGX. Image NGX 1.18. But it still failed because this image has a high severity vulnerability. And this Lego file doesn't allow high severity vulnerability. So let's try editing the config map to allow high severity. Okay. So here I'm adding the high severity. Okay. So after editing this Lego file, the kube management loads this Lego file to OPA service. So this deploy should be succeeded. NGX image NGX 1.18. Okay, created. So now we confirmed that it works properly with OpenProxy agent. If you use Harbor as a container registry, Trivy Enforcer can query Harbor to fetch vulnerabilities of the image, because Harbor supports image scanning in the registry. In that case, you don't need to add a custom resource for pre-scanning. So I have the demo of OPA integration with Harbor registry. So now we have the Harbor deployed in the Kubernetes cluster, and the version is 2.0.1. So it's the latest version, and the domain name is core Harbor domain. So there are some images under the project library. So library NGX and the library Alpine. So let's have a look at the NGX. It has only one tag, 1.18, and it has some vulnerabilities, including high severity. We need a different policy than the one we just used with Trivy, because Harbor has a different format of the scan result. So defining the policy for Harbor, the package name must be Kubernetes validating Harbor, and include deny with the message. In this example, it just denies the vulnerabilities of high and critical severity. I removed Trivy's policy used in the previous demo, so you can see the only one Lego file. So we have to upload the policy to config map. So this policy is also loaded to OPA service. Create config map from file harbor.lego, OPA namespace. Okay, create it and load it to the OPA. You can find the policy of Harbor in config map. So let's try deploying the image in the Harbor registry. So in this case, I'm using the core Harbor domain / library / NGX 1.18. But it was rejected because, as you know, this image has a high severity vulnerability. So this image violates the policy. So modify the policy to allow high severity. Okay, so let's remove this severity, high severity from the policy, and try to deploy the image again. Run NGX image core Harbor domain library NGX 1.18. So deploy is supposed to be allowed. So as you can see, the image has been created. So you can apply image assurance throughout the development lifecycle. In local development and continuous integration, you can run Trivy CLI with -- ignore policy option. Then, Trivy Enforcer can be used in a Kubernetes cluster to reject deploying the image with critical vulnerabilities. The important thing is that you can share the same policy across the whole process. Note that they are still experimental features and not stable. What I wanted to get across in this presentation is that we should define a custom policy for vulnerability handling based on your organization's risk acceptance. Then, Open Policy Agent can be used for that purpose. You can find some proof of concept as OPA Integration with Trivy. In those POC, you can take advantage of the same OPA policy throughout the development lifecycle. That's it. Thank you for your attention. There are a lot of software vulnerabilities in the world. Usually, CVID is assigned to each vulnerability. In the case of Heartbleed, CVE 2014-0160 is assigned.